Hi, this is Surendar. The topic is explain the use of principal components for description. Intro. Principal component analysis (PCA) belong to linear transforms based on the statistical techniques. This method provides a powerful tool for data analysis and pattern recognition, which is often used in signal and image processing. As a technique for data comprehension, data dimension reduction, or their de- decorrelation as well. There are various algorithms based on multivariate analysis or neural networks that can perform PCA on a given dataset. This introduce PCA as a possible tool in image enhancement and analysis. The PCA theory. Principal component analysis in signal processing can be described as a transform of given set of n input vectors with the same length k performed in n dimension vectors x. X is equals to x1, x2, so on up to x of xn into a vector y according to y equal to a of x minus mx. This point of view enables to perform a simple formula, but it is necessary to keep in the mind that each row of the vector x consists of k values belonging to the to one input. The vector mx in equation 1 is the vector of mean value of all input variables defined by relation. Matrix A in equation 1 is determined by the covariance matrix Cx. Rows in the A matrix are performed from the eigenvectors E of Cx ordered according to corresponding eigenvalues in descending order. The evolution of the Cx matrix is possible according to relation. As the vector x of input variables is n-dimensional, it is obvious that the size of Cx is n cross n. The element Cx of I comma I lying in its main diagonal are the variances of x, and the other values C of I comma j determine the covariance between input variables xi comma xj. Between input variables xi comma xj, the rows of A in equation 1 are orthonormal, so the invention of PCA is possible according to the relation. The kernel of PCA defined by equation 1 has some other interesting properties resulting from the matrix theory, which can be used in the signal and image processing to fulfill various goals as mentioned below. Stage of PCA for image compression. Data volume reduction is a common task in image processing. There is a huge amount of algorithms based on various principles leading to the image comprehension. Algorithms based on the image color reduction, the mostly lossy, but they result as still acceptable for some applications. The image transformation from color to the gray level image one belong to the most common algorithms. Its implementation it is usually based on the weighted sum of three colors components R G B according to the relation I equal to W1 R plus W2 G plus W3 B. The R, G, and B matrices contain image color components. The weight Wi were determined with regards to the possibilities of human perception. The PCA method provides an alternative way to this method. The idea is based on the equation 6, where the matrix A is replaced by matrix A1, in which only one largest eigenvalues are used for its forming. The vector x of reconstructed variables is then given by relation. True color images of size m cross n are usually saved in three-dimensional matrix P with size m cross n cross 3, which means that the information about intensity of color components is stored in the three given planes. The vector of input variables x in equation 1 can be performed as the n equal to three-dimensional vectors of each color, forming three one one dimensional vector x 1, 2, 3 from each plane p of m comma n comma I with the length of mn can be advantageous for better understanding and programming. The covariance matrix Cx and the corresponding matrix A are then evaluated and the three-dimensional constructed vector x according to the equation 8 can be called as the first, the second, and the third component of the given image. Matrix theory implies that the image obtained by reconstruction with the matrix A contains the majority of information, so this image should have the maximum construct. These properties could be significant in the following image processing. There is a selected real pictures P and its R, comma, G, comma, B components in figure 1. Its three reconstructed components obtained according to equation 8. For each eigenvalues are presented in figure 2, the comparison of intensity image obtained from the original image as weighted color sum evaluated by equation 7 and as the first principal component is presented in figure 3, the eigenvalues sorted in descending order belonging to the selected image so presented in the table 1. Figure 1 original image and its three color components are shown. First component, second component and third component are below. The comparison of various method of image color reduction. The gray level image evaluated as weighted sum of R, G, B colors and the gray level image counted on the base of the PCA method. Thank you.